Joining me today in the studio is the astronomer in charge at the Australian Astronomical Observatory at Coonabarabran, Mr. Fred Watson. Fred, the Australian Astronomical Observatory was taking part in what was known as the R.A.V.E. survey. Now, that was held up a little due to the fires that came through the Coonabarabran area in January. Could you, for all of us non-science buffs out there, give us, I guess, a little bit of background as to what the R.A.V.E. survey is all about?
Yeah, well, as you can probably imagine, the name is an acronym. It stands for Radial Velocity Experiment, which is gobbledygook terminology that means what we were trying to do and what we've, I think, achieved is to measure what we call radial velocities, and that just means speed, the speed towards or away from you of a star. But instead of doing it for one star, we've done it for 500,000 stars. So the R.A.V.E. project has been, the idea was to gather a lot of data on a lot of stars, more than just speeds actually. We've also gathered physical details of a lot of these stars. And the purpose of it is not just stamp collecting, it's not just to have a list of star speeds. It's all about trying to understand the structure of our galaxy and the way our galaxy has evolved in its 12 billion year history. So our galaxy being that huge disk-like aggregation of stars and gas and dust, of which the Sun is one member.
Now, Fred, forgive me for my scientific ignorance, but has this got something to do with the origins and time of the birth of the universe?
Well, yes and no. I think what you're thinking of is the expansion of the universe as a whole.
Correct.
Which is something else that we've done in the past with actually both our telescopes at the Siding Spring Observatory. But that's on a very much bigger scale than the scale of our own galaxy. Looking out into the universe, we see hundreds of billions, actually, of other galaxies. And by measuring them, you can look at the evolution of the universe as a whole and in its 13.8 billion year history. But the biggest objects in the universe are the galaxies. And galaxies themselves have got a very interesting history. And that's why for the R.A.V.E. project, we chose to look at individual stars in our own galaxy rather than other galaxies deep in the universe, which we have done before with the telescope. The point being that we'd like to understand the way galaxies are put together and how they themselves have evolved since the very earliest times in the universe.
What can we take out of the results of this survey now that we have a better idea of the speeds of movement of other stars in our galaxy?
Probably the most important outcome is something that astronomers have suspected for quite some time, and that is that galaxies like ours, big spiral-shaped disks of stars and gas and dust, that they grow by gobbling up other galaxies, a process that we give the slightly politer name of accretion to. We call this accretion, which means that galaxies actually swallow up neighboring galaxies. And the evidence for that comes indeed in the speeds of stars, because what happens when you look at stars all around the sky, which is what we've done in the R.A.V.E. experiment, you find some stars which have got a common velocity. That's to say they're moving in the same direction and at the same speed. Even though they might be on opposite sides of the sky, they have this property in common, that they're moving as a whole. And when you look at large numbers of stars, you can pick out what we call streams of stars, which are moving in the same direction and at the same speed. And indeed, we've identified a number of those. And the normal interpretation of what we're seeing there is that these are the remnants of smaller galaxies which have been swallowed up by our own galaxy. So this is all about determining the history, as I said, of our own galaxy, the way it's grown by absorbing other ones.
The Coonabarabran Siding Springs Observatory took part in the R.A.V.E. survey. Were there any other telescopes or observatories that also played a part in this survey?
There were institutions, because R.A.V.E. is actually a multinational project. It's supported by astronomers in 9 nations, most of which are in Europe, although the USA and Canada are also participants. But the only telescope that was used was the United Kingdom Schmidt telescope, which is operated by the Australian Astronomical Observatory at Siding Spring Observatory. So yes, just one telescope, but a lot of astronomers from all over the world contributing to the project.
I understand the fires that ripped through the Coonabarabran area earlier in the year held up the project for some time?
Yeah, that's right. Well, the project has been running for 10 years. We took our first observations on the 11th of April 2003, and it was scheduled to begin pretty well at the end of January this year. But of course, the fire went through Siding Spring on the 13th of January, and that stopped all operations. And in fact, basically shut down the observatory for a while. Gradually, the observatory has got back to normal. It's pretty well back to normal now. But at that time, the R.A.V.E. project was almost finished. We were something like 10 observing nights away from the end of the project. And some people said, you should just wrap it up now because, the fire's finished it and that's the end of it. But I did not want that to happen. I wanted our project to end in a neat and tidy fashion with the conclusion of the observations. So in fact, it finished. I did the last observations on the night of the 4th of April, and that completed the project. So, as I said, nearly 500,000 stars over 10 years, almost 10 years to the day between the first observation and the last observation. And I think a lot of astronomers throughout the world who've used R.A.V.E. data and are using R.A.V.E. data in their scientific research, I think they're very happy with the results.
It would be hard not to be happy with such amazing results and information. Moving along to the Australian Astronomical Observatory website. On the website, there are quite a number of detailed colour photos and images taken from the telescope. Now, were these taken with some sort of specific purpose, or is this just part of a PR exercise to get people excited about astronomy and science in general?
Actually, all the photographs that you can see on the website were taken for scientific purposes. So they were all images made with specific research projects in mind. But in the observatory's early history, we had a very, very talented astrophotographer on the staff, a man by the name of David Malin, who became world famous as being the first person to work out how to take true colour pictures of the night sky. He used a three-colour imaging process, which he pioneered at what was then called the Anglo-Australian Observatory. We're now the Australian Astronomical Observatory. And one of the spin-offs of that process was, of course, all these beautiful pictures, which are indeed on our website, and they were naturally turned into something of a PR exercise. Even though they were taken for scientific reasons, their aesthetic value is extraordinary. And so these pictures actually helped to make the observatory world famous in its early days, and they're still among the finest astronomical photographs in the world. So we're very proud to have them on the website.
Now that the R.A.V.E. survey has finished up at the observatory, what's next? Are there other studies in the pipeline, or are there always multiple studies and multiple events happening at the observatory?
Well, yes, there are. One of the things to remember is that Siding Spring Observatory represents a number of different institutions. The site is actually operated by or owned by the Australian National University, and they run two telescopes there, which are doing different projects. We at the Australian Astronomical Observatory also run two telescopes, one of which is the biggest in Australia. That's why everybody thinks we own the place, but we don't. We're tenants. Our telescope is on the ANU site. That's the Anglo-Australian telescope, and that telescope is indeed continuing with its research program. It looks at things like the study for discovering new planets going around other stars. It also is involved with projects to try and determine what is the nature of two of the biggest mysteries that confront astronomers, something called dark matter and something quite unrelated to it called dark energy, neither of which we know too much about, but we are exploring those. But the smaller telescope on which the R.A.V.E. project was carried out, the Australian Astronomical Observatory Smaller Telescope, that has now completed its work as far as the particular type of observations that it's making at the moment are concerned. But the plan is we have another project in the pipeline, a project called Taipan, which is also an acronym. I can never remember what it stands for. Taipan is a project which will allow us to do what you mentioned earlier, to look at galaxies in the universe and the way the universe is expanding. But to do that, we actually need to modify both the telescope and the equipment that we use to make the measurements. And that's probably a 2-year project. So there's going to be a gap in what the telescope is doing while we modify it to bring it up to a new standard of excellence to make these measurements of distant galaxies.
Mr. Watson, thank you so much for your time today. I do appreciate it. I just have one last question for you, and I hope I don't put you on the spot too much. In your opinion, what do you think is the most exciting discovery or the most exciting scientific study that I guess is currently being undertaken?
It's hard to pick because there is so much absolutely staggering science going on at the moment. Astronomy is in a golden age. We're discovering so much about the universe. One of the things that I always tell people is that the universe is probably more bizarre and more extraordinary than we can ever begin to understand. But one of the things I think that grips most people's imagination, and this is very much an active field of science at the moment, is the search for life elsewhere in the universe. It's a subject called astrobiology. And our observatory is engaged in that, as are a number of other observatories around the world, looking for hints that we might not be alone. In other words, that somewhere else in the universe there is life, maybe even only rudimentary life, but nevertheless living organisms. And I think that's one of the most exciting quests that we're engaged in at the moment.
Mr. Watson, thank you so much for your time today. I really do appreciate it.
Not a problem, Victor. Good to talk to you, and thanks very much for your interest in R.A.V.E.